Where do I start and what is step-by-step process to become a data scientist? There is no guaranteed step-by-step guide for most careers, as everyone will have different starting points, strengths, and weaknesses. Also, data scientist is a broad term that encompasses many different kinds of roles. However, there are a few steps you can take to help yourself get there. Step 1. Mentality. Figure out what kind of data scientist you want to be. This may sound a bit preachy, but it's very important. To achieve your goal, you need to have a solid understanding of what your goal actually is. Traditional analyst, data infrastructure, predictive modeling, machine learning, or deep learning and AI. All of these require different skills, so you should think about it early to pick up the right skills. If you want to be an analyst, be curious. I'm not sure if you can train yourself to be more curious if you aren't already, but most analyst roles are about using data to answer questions. If you don't care about the answers that your data can give you, you will not be driven enough to succeed or dive deep into the data. You also won't look into problems at many different angles. If you want to build things, be prepared for things to not work, and not be perfect. Make sure you're ready to prepare for and test for edge cases, or fix and debug things that do break. Learn to be okay with shipping a product that's not the best that it can be, but is better than what's currently out there. You may learn this on the job, but at least build a good framework for the cycle of building and breaking. Step 2. Learning. Find out what you're deficient in, and learn it. This can be self-taught, internet, books, or through formal training, certificate programs, boot camps, undergraduate, or graduate school. Choose a method that is within your budget, within your desired timeline, and aligned with your preferred way to learn. Statistics and probability, especially if you plan to be an analyst. This is important to make sure the data results you find can be justified, so that you do not jump to conclusions based on correlations that occurred by chance. Topics to understand: set theory, basic probability, or cumulative distribution functions, PDFS or CDFS, expected value, key distributions, uniform, binomial, geometric, Poisson, Gaussian, p-values, confidence intervals, statistical power, p-tests and t-tests, Markov chains, bias, and variance. Cognitive biases, analyst roles and data understanding. Confirmation bias, survivorship bias, etc. Big data, important for analyst or data infrastructure roles. How to get the data you want from databases. How to work with large amounts of data. Things to learn: SQL, distribution, or sort keys, data structures, data logging, data pipelines, Hadoop, Spark, Hive. Programming, important for all roles. However, it's less important to know a specific language than to be proficient in at least one language and comfortable with reading documentation. Analysts tend to use high-level languages like Python or R. Most machine learning is also done in these two languages now, alongside C++ and Java. Deep learning typically uses TensorFlow or Python. Infrastructure and engineering roles will typically use languages such as C++ or Java. This really depends on the company, however. Many roles will also require you to be comfortable using a terminal or command line or shell interface. In particular, Macs are quite popular nowadays for devs, so Bash programming will be very helpful. Machine learning, important for predictive modeling and machine learning roles. Having a strong foundation in math and linear algebra also really helps in learning the following topics. Things to learn: statistical learning theory, data preparation, data cleaning, linear models, linear regression, logistic regression, support vector machine, kernel methods, nonlinear models, tree-based models, neural networks, Bayesian models, M-algorithm, distance-based methods, k-means, k-nearest neighbors, principal component analysis. Deep learning, important for AI roles. Things to learn: difference between reinforcement or supervised or unsupervised deep learning, backpropagation, data augmentation methods, common modules, and their purposes, linear, ReLU, TAN, dropout, batch norm, softmax, common architecture patterns, convolutional neural networks, recurrent neural networks. Step 3. Credibility or resume building. This step can be highly correlated with the previous step, depending on if you choose a learning method associated with more natural credibility, higher education, or one with less natural credibility, self-taught. Projects. Obtain some data or use some data that you have. There are plenty of open data sources on the internet. Or you can join a Kaggle competition. Dive deep into the data, find out something interesting, and write a blog post or Medium article about it. Or, build a model and also share your results. Network. Attend data science conferences and talks to meet other data scientists. Reach out to your personal network for job recommendations. Volunteer or apply for research roles or internships. Step 4. Apply and interview. Last step. The learning process for a data scientist interview can be different from the things you learn in Step 2. In particular, most interviews focus on algorithmic programming, SQL, problem-solving ability, conflict resolution ability, product understanding, and culture fit. There are also many resources online that can help you prepare for each of these aspects, so I won't go into detail. The key is to practice, practice, practice. Apply, failed, learn from your mistakes, try again.